There we go. So I just threw it in and it came out to negative 11. So we now have our vertex. And we saw yesterday a lot of things are based off of that, or you need it to graph to find your points anyways. So that vertex is usually kind of the most important thing with quadratics. So let's talk about some other stuff we talked about yesterday. Our stuff will kind of get used to labeling. One is the axis of symmetry. So that's that kind of vertical line that acts as the mirror to make it symmetrical. And the axis of symmetry is always going to be x equals whatever the x from your vertex is. So that's why the vertex is important. A lot of things are based on it. A lot of times we'll ask, is it a max or a min? Maximum or minimum? Yesterday we had written down some stuff about A, and the same thing holds here. This A and the vertex A are actually the same. So if we had put it in vertex form, A would still be 2. Since this is positive, it opens up, which means it's a minimum. If this was negative, it would flip it, it would open down, and it would be a max. So it's all based on just your A being positive or negative. We asked about yesterday domain. There's no restrictions here, so it's just all real numbers. We asked about range, all the good stuff here. Range we can do without the graph. It's always y. Since our vertex is a minimum, everything is above it. So we're going to say is greater than or equal to. And then it's just the y from your vertex. That's a nice thing. A lot of these, like, you don't want to have to actually graph to find them. So a lot of them you can kind of just use with reasoning. Yesterday, someone asked in here, and I didn't mention it. One of the questions yesterday, and I wanted to go over it today, was how to find the y-intercept. Vertex form we'll do in a little bit when we go over the homework. But for this form, it's easy because your C is your y-intercept. So I'm just going to label it as 0C because we write it as a point. So if it ever asks for a y-intercept and it's in standard form, it's just whatever your C is. So in this case, our y-intercept is 0, negative 3. Delightful. When it's in vertex form, you do have to do a little work to find it. And then what was the other thing? Oh, x-intercepts. Man, this is a lot of labeling. We haven't even graphed yet, but that's okay. That's why we're only doing 2 problems today, guys. This one and one other. X-intercepts, we plug in a 0 for y, right? So we're going to plug in a 0 for y. We're going to solve for x. I don't think that's factorable. Let me check. I'm just checking the discriminant. Ooh, going back to last chapter. It is not factorable. So I'm just going to use quadratic formula. Because it kind of lends itself since it's not factorable to that. So it's going to be negative b plus or minus the square root of 88 all over 4. Let me simplify 88. It's just divisible by 4, right? So it would be 2 root 22. And then I can reduce that. Those are all divisible by 2. Now, if you were like, hey, like that, those are the x-intercepts, like graph them, I'd be like, I don't even know where those are. So a lot of times if we ask for x-intercepts in terms of a graph, we will just get the decimals just so we can kind of get the approximate place they are. So I'm going to find that as a decimal as well, or as 2 decimals, I should say. So the first one comes out to about 0.345. Oh, 345. And then negative 4.345. Okay. So if you're graphing, once again, if you were to like graph that radical, I'd be like, I have no clue where that is. But we'll go with it. And then last but not least, guys, we haven't even graphed anything yet. That was the main goal in the end, was to graph that bad boy. You guys see me? Yeah, you can see me. Okay. So graphing, I always start with the vertex, -2 and -11.
I have a question about graphing.
Yeah.
Do you always have to do the thing where you find two other points? Or if you find the vertex, the y-intercept, and the x-intercept, do you not have to find the... Because it doesn't that kind of give you the shell of it anyway?
Maybe. I mean, yeah, because your intercepts, I mean, ours just aren't going to be very exact. I guess we could kind of like estimate where they are. Whereas our y-intercept we know is at -3, so
You know
I
what
know
I mean?
that point. Because you could just reflect it across.
Yeah, that's what I'm saying. Like, do you have to, or can you?
It's just if your intercepts aren't like beautiful, I want like nice points, you know.
Yeah.
So I'm gonna find a few other points, you know. I'm stuck in my ways here. I always do vertex in the middle. A few X's to either side. I already know that the 0 is going to be 3, but I do it this way. You can technically just find 2 and then they should reflect. I'm the queen of like going too fast and putting things in the calculator on, so this is more just to check myself. I plug each of these X's back into the original equation. That should come out to -3, which is, excuse me, that's -3. Which it does, and then let me just check the -3. Beautiful. Okay, so it is symmetric. I'm good. Once again, that's just more me checking myself because I tend to rush and make silly mistakes. And we can see that just reflects across. What's this negative? That reflects there. And then we have a nice old thing. So once again, sure, that's about 0.345, and sure, that's about -0.4345. Obviously, if it's not an exact intercept, you're just kind of estimating where it is. And that, my friends, is all this stuff. Now, are we saying every problem you're going to have to do all that? No way, because that would just be a big pain in the butt. That's just all the stuff we might see. Depending on the problem, you might have to do 1 or 2 of those things. I don't even know if any of the problem set you have to even do all of this in your problem set. So that's just more to go over kind of everything at once, just because we have the numbers up there. But some of the things, we'll talk about the problem set later. You'll see you don't have to do all of that at once type deal. So just as a heads up there. So I'm just giving people a second because I know that was kind of a lot of stuff. I'm just gonna kind of give you one and have you label a few things and see how you're feeling. And if you have any questions, and then I do want to go over those homework problems that you guys tried. Sorry, I'm just trying not to rush people. Okay, so let me give you a new equation here. Oh, there's a lot going on in this problem. I'm just erasing everything. Here we go. All right, so say my equation is y is going to equal -x squared minus 6x plus 5. Okay, so that's a quadratic equation in standard form. Can you label the vertex, the axis, symmetry? I always want to not label that, the whole thing. Is it a max or min? The domain. The range. The y-intercept. The x-intercepts, oh my gosh. Once again, I don't think there's any problem in that you actually have to do all of these. It's just kind of combining everything so we don't have to do a million different problems. And last but not least, can you graph it? Oh my gosh. Remember, the graph is great, but you actually don't even need the graph to actually answer any of these, right? You can just do most of them kind of by visualizing, using algebra. So as much as we're talking about graphing, a lot of the labeling you don't necessarily need it for, which is nice. But just make sure you're comfortable with every individual piece. Well, I take a 10 minutes. Oh, I'm so happy it's Friday.
After we finish these problems, can we do questions from the pig?
If we have time, I just want to go over that homework real quick. If we have time, we can. I know, I need to.
We haven't done the pig in so long.
I know, we're really. I know, we're all messed up with our schedule, that's why it's like between being remote and then snow days and vacation and quarantine and life. We're a hot mess here. Beautiful. Oh, my goodness. I'm gonna kind of just start to do mine, and then I can check if we go.
If it's negative, then it's math.
Yes, that's where you, yes.
The opposite of what you think it would be.
You flip, yeah, I know, yeah, you flip it upside down. And then just be careful also when you're plugging things into this, because it's negative x squared minus 6x squared, so just always use parentheses. That's not gonna be your, parentheses are always your best friend in the calculator, because if you don't use them, sometimes it gets all messed up. So vertex is negative b over 2 times a, which would be negative 2, so that's negative 3. I'll plug that in. So just make sure, kind of check this vertex and make sure we're on the same page here. Your vertex should be negative 314. Once again, if you got the vertex wrong, huh? Because it's negative, and then parentheses, negative 3 squared. Remember, that does not turn that positive. It says negative 3 squared and then makes that negative. So don't do a double negative as a positive. And then minus 6 times negative 3 plus 5. So retry that bad boy in your calculator. But yeah, just be careful. The order operations on that one can mess you up. So be careful, because then everything is based off that. So this is x equals negative 3. Since this first one's negative, it opens down and it's a max. Everyone should get the domain, it's all real numbers. The range is y. everything's below, so it would be less than or equal to 14. The y-intercept we like on standard form because it's just kind of there, it's your c, so we write it as the 0.05. And then the x-intercepts I'm going to have to do a little bit of work for. So I'm going to set that equal to 0. That is not factorable, so I'm going to just use quadratic formula. I guess you could do, like, if you made that positive, you could do completing the square. Whatever works for you, works for me. So that's negative b plus or minus. Let me find out my discriminant. My discriminant is 56. That would be over negative 2. That's divisible by 4, so that would be 6 plus or minus 2 root 14 over negative 2. And then as you're just finding your final x-intercepts, for the exact, we don't want negatives in the bottom, so I'm going to kind of just divide by negative 2 as I'm dividing that out. Remember, it doesn't really affect these because those just flip, so they end up being the same. But that ends up being negative 3 plus or minus the square root of 14. So that would just be over 1. Just to kind of visualize, I'm going to find those as a decimal as well. I get 0.74 and negative 6.74-ish. Okay, so we did all that without even graphing anything. I was just kind of knowing what to look for, what you needed. Most things kind of relate back to that good old vertex there. So make sure you're good with that. And then if we actually have to graph, I'll just kind of do some points and go from there. So we have negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we kind of ran out of room, but you got the idea. And I'm always off a little, it's about a weird angle. So I'm just going to find a few other points. Once again, you can use what you have, but like this isn't exact. So we want some nice points, but you can use the intercept if you'd like. I'm just going to find a few things to either side. I know it should reflect. What do I got? Negative parentheses, negative 5 squared minus 6 parentheses, negative 5 plus 5. That comes out to 10. That comes out to 13. And then I like to do the other side just to kind of check that I didn't make any silly mistakes here. That it's a nice, very beautiful reflection, and that's 10. Perfect. So once I have my other points, I'll just plot those quick, and then I'll finally be done. These nice little problems, but they take forever. I think I'm in the right spot. Good enough. You guys get the idea. Once again, my intercept is off a little. It should be up at 5, but. Okay, once again, I don't think there's any problem you actually have to do that, all those things at once. But I figured instead of us doing like 8 different problems, we'll just do one problem with kind of an overview of everything. So just as a heads up. Okay, so I'll leave that up for a second. I do want to look at your homework from last night, because what's the point of doing it if we aren't going to check it, such a deal. So I'm going to throw the answer key up to that. Okay, let me do that. Sorry, I need to find my answer key. I'm getting distracted easily here. Oh, I need to turn on this. I need to check. Who we got? This. That's not what I want. Where is it? Where's that little spin? All right, so let me put this down. So anyway, I have like 8,000 things up. Show it to you guys at home and you guys here. And computers don't work. Turn the light up. Let's see. All right. Oh yeah, that's beautiful. Beautiful. So let's kind of do a quick glance and see if there's anything major that's sticking out of this that's being confusing or what you'd like to go over or anything like that. So as I'm looking at number 1, this is the one I was kind of talking about. Vertex, I like vertex because it's vertex form, so that's pretty easy. But the y-intercept there might have thrown you off a little bit. If you ever need to find a y-intercept, and it's not in standard form, so it's not necessarily obvious, you can plug in a 0 for x, right? Because anything on the y-axis means that x is 0. So I can throw in 0 minus 1 would be -1, squared would be 1, and -4 is where I got my -3 from. So just as a heads up, if you don't know something and you need an intercept, you just plug in a 0 for the opposite variable. So just as a heads up there. I'll open up or down, you can see it's up. Axis of symmetry we get from the vertex. The zeros, I think I actually just got them from my graph because I did the points, and then that is a minimum. So the other ones are pretty similar to that, where you're finding kind of the same info, the vertex, the intercept, up or down, axis of symmetry, the zeros, max and min. So just do a quick check. Is there any questions? No, let's give you a minute. Sorry, we're always in a rush in block 7 because of this dismissal craziness. But are there any questions on those few first kind of graphing problems? Sorry, I don't know if someone mentioned. Okay, no, good. I'm paying minor noise and I never know what that actually means. Okay, eventually I'll put this up too, but for now I just wanted to kind of at least check in with you guys. So 4 and 5 were nice because you did the labeling, but you didn't have to actually do like the annoying kind of graphing part. So you were just doing vertex. Once again, from vertex form isn't bad. The axis of symmetry. The max. Oh, I think that's because people keep getting like kicked off. Oh, Pierce, do you have a question?
Yes, sorry,
Okay, just turn it in as soon as you can. Not a big deal. Okay. Sorry, I can't. I have 2 computers up and none of them I can actually see anyone, so I'm trying to get the answer stuff on. So yes, feel free to just yell at me. For 6 and 7, you were just doing a quick graph. It didn't really even ask you to label that much, so I just found a few points and kind of threw those in. I just wanted to point out 8 and 9. Those were the ones I didn't want you to be stuck on. So we had done these problems yesterday. It's just for us, they had a different setup. Because when you're writing vertex form, you're feeling pretty good when you find the vertex. You're like, oh, okay, I have like mostly everything I need. But you can't tell what A is just by looking at the graph. So I had to do the steps from yesterday where I had the vertex, and then I just found like another point. You just want to make sure it's an exact point. You don't want it to be like half through a point. So find another exact point. And then I did the steps that we did yesterday where we plugged in HK and XY and I found A. So I thought that one maybe like just out of context and not having the same setup as yesterday might have confused you. So that's why I wanted to show it to you. And then the same thing for 9. I can find the vertex pretty easily just by kind of looking. But once again, to write an equation, I need A and I can't tell what it is. So I have to use the vertex, HK, and then just another point on the graph, which is just XY. So you could use a different point, but that's the one I chose. And then you go back and solve for A, and then you can write your equation. So that was one thing I thought, we did it, but just it wasn't the same really. So just as a heads up, that's how the setup of those should look. If that confused you a little bit, sorry. And then 10, if you weren't like super exact on the directions, it's fine if you kind of just tried them. It just says to describe the transformations. We had actually done it. This was one of the first things we did at the beginning of the year was transformations, moving up, down, right, left, compress, stretch, flip, all that fun stuff. That's not that. So those were just some of the transformations of those, moving to the left and compressed, left and up and flipped and all that fun stuff. Once again, 13 was so annoying that you skipped 13 and I will respect that. So those were the ones you were working on last night. Our goal is to kind of keep working on this problem set just to practice. I'm going to give you problems tonight. I'm not going to check them Monday. I feel like it's kind of like I don't want to do work this weekend. I'm going to be honest. And like we all just need a break sometimes. But it's one of those, like, maybe on Monday morning you have a study during third block and you're like, oh, I wish I could just get it done so I don't need to do it later type deal. Or if you have time and you want to get it done, that's fine. So I'm just going to give you the next kind of few problems. We're going to go a little bit out of order because there's word problems and we're going to kind of skip those for now. So once again, I'm giving you some problems right now. I'm going to say they'll probably be due Wednesday. So just as a heads up. So that gives you plenty of time to start them. Wednesday, I'm actually not going to be here. I know it's a virtual day, but we won't even have a meet. My son has his ear doctor appointment. Fun stuff. So we'll say Wednesday, like at the end of the day, I'll kind of just like put in your work. You'll have plenty of time because I won't even really see you. And go from there. But let me give you kind of the next few problems. If you want to get them started, if you're comfortable. Sorry, I'm losing my mind. Comfortable doing them, great. If you, it's like really dark in here now. If you want to do them later.
Wait, what just happened?
I turned off the
Oh, I
projection.
genuinely just thought.
It's like super dark because I have my curtains up.
I was like,
Look at how dark it gets. I know. The light blocking.
I was like, did the power go on?
No, that's the point of the light blocking thing. All right, so here are the next kind of problems that we'll work on. Problems number, where am I? What class am I in? It's 14 to 17 and 24 to 31. So it's a little bit more with vertex form, and then it goes into some standard form stuff. Some stuff you're just, sorry, it's up here. Some stuff you're just kind of labeling. I think there's a few graphs. But we'll kind of try to work our way so we're not killing ourselves at the end. Once again, I'm not technically checking this on Monday, but it should be due by like Wednesday-ish. And we're going to have more stuff we do next week, so just keep that in mind. And I think that's it. So once again, just write down 14 to 17, 24 to 31 is kind of the next few problems we're working on. So other than that, the peeps, I don't really have like 2 minutes before people start getting dismissed here. So the peeps